In this problem, we're trying to determine the total volume of the products, the gas as gases. We have up here the combustion or metabolism of ethanol, C2H6O, metabolized in the presence of oxygen, and the products CO2 gas, H2O gas. With 39 grams of ethanol to begin with, what is the total volume of the products? With this chemical reaction up here, it is first unbalanced. So let's start by balancing it. I have carbon, hydrogen, and oxygen to balance out. So I'm first just going to start by balancing out. I'm just going to go in order, start by balancing out the carbons. There's 2 carbons over here. So I'm going to need at least 2 carbons on the product side. So if I put a 2 there, there's dose CO2, so that means that there's 2 carbons on each side. Hydrogens, there's 6 hydrogens in ethanol, and our product is water, so we're going to produce more than just 1 water. We're going to produce, say, 3 waters, because that gives me 3 times 2 is 6, and there's 6 waters there. So it looks like our carbons are balanced out, our hydrogens are balanced out. Let's balance out the oxygens. So here I have 3 oxygens on this side, and on this side I have 4 oxygens, because in dose CO2s, that means that there would be 4 total. And I have trace H2 unos. So that gives me 3 more. So that is 4 plus 3, that's 7 oxygens. An odd number. All right, now if I have a 2 here, that gives me 5 to 7 oxygens. Oops, not quite. Let me just do this up one more. Let's put a 3 here. 6 plus 1 is 7. 7 over here. So let's just double check everything. 2 carbons, 2 carbons, 6 hydrogens, 6 hydrogens, 7 oxygens, 3 plus 4, 7 oxygens. So now we have a balanced chemical reaction here. We had 39 grams of ethanol. What will be the total volume of the gases produced right here? We're going to solve this problem in 2 steps. The first thing that we're going to do is we're going to calculate how many grams of CO2 would be produced. And then once we have the grams of CO2, then we'll calculate the liters of CO2. And we'll do a similar thing with the H2O. How many grams of H2O? And then how many liters? And then sum those answers together. So a grams to grams type problem is an oldie but a goodie. 39 C2H6O ethanol. We're going to look this up in the periodic table to figure out the molar ratios of CO2 of ethanol to CO2. Get there. 2430. That's about 46 grams per mole. Adding that up off the periodic table. Now in this next block, I'm going to make ethanol cancel out. So C2H6O, and I'm solving for CO2. So I'm going to carry on the coefficient from the balanced chemical reaction. Stuff is canceling. Moles of CO2, and then finally solving for the grams of CO2 right here. So I need the periodic table to get the grams per mole. 32, 42, about 44 grams per mole. I'm just rounding here. If you want to take these molecular weights to 2 decimals, that's fine. That's going to give us our grams of CO2. Now I need a calculator. Getting 74.61 grams of CO2. So that's our grams to grams calculation. So now using ideal gas stuff, we can calculate how many liters that must be. Now, when talking about gases, the ideal gas constant's in play, and also PV equals nRT, but we don't need to rearrange PV equals nRT. We need to focus on the unit we're digging for. We're digging for liters. So let's start our scaffold with that unit right where we need it. So I set up my scaffold to have liters on top. That's where we need it right there. Now, a couple things I didn't mention because it was too much to I didn't want to blow up with so many numbers right here, was for these gases and to solve for this problem, we need a temperature and a pressure. And just to kind of keep things rounded out right here, let's just say the temperature is 300 Kelvin and the pressure is 1 atm. And that would be given to you at the beginning of the problem. We can already cancel out some units here. Kelvin, Kelvin. ATM, ATM. Okay. Now I need to cancel out moles. I do have the grams and that chain link unit. The unit that connects grams and moles together is from the periodic table. And because we're trying to find this for CO2, we're going to look up CO2 off the periodic table, 44 grams per mole, 16 plus 16 plus 12. That makes our moles cancel. And now finally, to make the grams cancel out, everything is canceled out except for liters without using PV equals nRT. Having the scaffold, having the units guide us. I'm getting 41.76 liters. Of CO2. Now, if you kind of rewind a bit, you notice that we used, at here we had to cancel out moles of the gas, and we used the periodic table to cancel out that unit of moles to put the grams in there. Okay, we're going to solve this water right here in a little different, a little more advanced way. You could solve for the volume of the water just as we did. Solve for the grams and then solve for the liters. For this right here, we're going to do it in one scaffold, going from moles of water to liters of water. So we're kind of starting over from scratch because we are going to start again with the 39 grams of ethanol. I'm going to try to do this in one big long scaffold here. 39 grams of ethanol, and I want to get to the moles of H2O. So as long as my scaffold has moles and H2O in the numerator, it'll solve for this. Well, let's look at the periodic table. 24, 30, 46, 46 grams per mole added up from the periodic table. Grams cancel out. It is a 1-to-3 ratio from the balanced chemical reaction, C2H6O. These are the exact same steps we did except with CO2. Now is where things will look different. Note that here in the numerator, moles and water are the only things that are remaining. So we are talking about, right now, if we were to pick up our calculators, we would be able to calculate the moles of the gas, H2O. Now we want to find the liters of the gas. Now, moles and liters are both in the ideal gas constant. We're not going to use PV equals nRT. We're going to make sure our units cancel. So let's make sure liters is in the numerator and moles cancel, and everything will work out. 0.0821 all right, so double whammy, moles cancels out and liters is still in the numerator. Now we need to cancel out ATM and Kelvin, and because we're talking about consistent circumstances, we still have 300 Kelvin and 1 ATM to play with. Note that everything cancels out except for liters and water. So when we punch our numbers up here, we're going to get the volume that gas would occupy, 62.64 liters. We want to know the total volumes is going to be about 103 liters when you sum them together. Hope that helps. Thank you.